In this lesson, we are going to control a servo motor using ESP32 and ESP32 extension module from Sunfounder that is powered with battery. So this is 270 degrees, and I'm going to show you how to control a servo using the knob or potentiometer. ESP32 starter kit from Sunfounder. This is the best ESP32 learning kit from Sunfounder. It has this ESP32 microcontroller which has built-in Wi-Fi and Bluetooth. This board can do everything Arduino Uno can do or many other Arduinos can do, plus extra more features. Because we have Wi-Fi and Bluetooth, the possibilities are endless. You can get connected to the cloud or do the control or read information or values via your mobile device or your desktop or over the cloud from a far location. It comes with a camera extension kit where you can stream the video over Wi-Fi either through the cloud or to your network, and also it comes with micro SD card where you can save images on the micro SD card, or you can write from the device any information, log the information on the device and read it back. You can power the board using this included 18650 lithium battery, and it has built-in charger where you can connect micro USB and charge the battery. The kit comes with 320 pieces of component that you can learn tons of projects. In this lesson, we are going to learn how to use this micro servo motor. This is called SG90. This is very famous and cheap, and we can set it and send it to a specific angle very precisely, up to 1 degree. So this can move 180 degrees. You see this side is long, and if I rotate it, it's around 100. It's supposed to be 180 degrees. There are different sizes. This is plastic gear, and there is also metal gear servo, the same shape and size, but it might be a little expensive. And there are larger size servo. For example, this can handle up to 60 kilograms with this arm. You can pull it and position it at precise angle. As you can see, this also works from 6 to 8.4 volts, so this is not 5 volts. Also another servo which was used before, and this is also all metal gear, very heavy. The servo motor has just 3 wires. One, the darker wire is always the ground, the middle wire is the power supply. In this case, it's 5 volts. And then the orange or white you will see is always, in this case, for example, white. White is the signal. And as you can see, this is black, red, white, and this is black, orange, white. But the middle wire is the same, the power supply. This servo motor comes with 3 arms. And as you can see, we have 1 half arm and then 2 double-sided arms. One is short, one is long. Sometimes you need to put this with equal length, and then something will be attached to this. So, for example, wing of airplane or a boat or something can be pulled. Or if you need it, you can put the one that is short or long, and based on the need or adjustment, you can attach it to different holes, or maybe the half arm. And here, this is the metallic one, also comes with metal arm, very long one, and it comes also with all these plastic arms for different application. And it comes with a lot of hardware and screws. So we have screws here where you will attach the servo arm like this. The servo is controlled with a signal that goes to it with a pulse width. And here we set the minimum and maximum pulse width for the servo signal. This is 500 microsecond, which is 0.5 millisecond, and this is 2500 microsecond or 2.5 millisecond. And as I mentioned, for majority of the servo motor this will work, but if some servo needs different value, you can enter it here. come to this page, docs.sunfounder.com, scroll down until you see ESP32, then click on ESP32 Starter Kit Main. On the left side, click on Arduino User, and on the left side, click 4.3 Swinging Servo. This is the documentation for our lesson. They talk about how servo motor is used, and we can precisely rotate it and put it in a specific angle, and it has been used in airplane models, aircraft, cars, steering cars, and so many other applications. For this lesson, we need ESP32 board, we need ESP32 extension board, both of these from SunFounder, jumper wire, and then the servo motor. And we can use these pins for the servo motor, and servo motor has simple 3 wires. Ground, the middle is always the 5 volts or power, and then we are going to connect it to pin 25. I'm going to show you. And here is the wiring picture. I'm going to show you. We need to install the library for ESP32 Servo, and here is the code, and I'm going to explain it. There is some explanation, which I'm going to explain it within the code. Now let me do the wiring. For the wiring, we need to have male to male. This is female, and we cannot attach it here. Get male to male wires. So I got this male to male from. You can insert them like this. The wire will be ready. But because this will not hold, to make sure to tighten it or put a tape, I have this DuPont wire. I'm going to connect it. I selected the same color, so I'm going to insert it to the connector. And I have the same color. I'm not going to make mistake. So the wiring is very simple. Look here, ground. I mentioned ground is connected to the ground from the last second, and then 5 volt is connected to 5 volts. This red, the last pin is 5 volts when you hold a USB this way, and then the signal pin is connected to 25 like that, and the wiring is completed. Now let's see how we can select the ESP32 board. We can click here under the select board and type here ESP32 DEV. As soon as you type dev, you will see dev board. You can select it and click OK. So the board has been selected. Now we have to select the port. The other way to select the board is click on Tools, Board, ESP32, and select the ESP32 dev module. Now we have to select the port. If I click here, it shows 2 ports, and I don't know which one belongs to my device. Sometimes you will not see the number properly. So the best way to be sure, right click on the Start menu, go to the Device Manager, and you will see here the ports. If I click on this arrow, it will show me the ports. One is USB serial CH340, the other is USB serial device. And here, now it's connected. If I disconnect this, one of them disappears. The one that disappeared is my board. So 6 stays and 8 disappeared. If I connect it, so 8 is my COM port, CH340. Now 8 is my COM port, and I can select it. Or I can click on Tool, Port, and here you will see it. You can select whichever you want. Ours is COM8. Now we have successfully selected the board and the port. And this is very important. It must be done first. I'm opening Arduino IDE. Let's open our project by clicking on File, Open. On the left side, click on Downloads. Then ESP32 Starter Kit Main on the right side. Double click to open it. Double click on C. Double click on Codes. And scroll down until you see 4.3 Servo. Double click, open it. Select Servo 4.3 and click Open. First, we need to install this ESP32 Servo, which is needed. As you can see at the top, it's included. Let's select this and copy it so we don't have to even type it. Click on this icon, library icon, and here right click and paste it. You'll see ESP32 Servo by Kevin. Install it, and installation is completed. Click to exit. So from this class, which is called Servo, we create an instance of the Servo called My Servo. You can name it, for example, Robojax or Sunfounder, whatever you want, as long as it's not a common names or reserved name by Arduino. And then here we define a pin for Servo, which is pin 25 of type integer, and then we put constant, so this cannot be changed. And here we set the minimum and maximum pulse width for the Servo signal. This is 500 microsecond, which is 0.5 millisecond, and this is 2500 microsecond or 2.5 millisecond. And as I mentioned, for majority of the servo motor this will work, but if some servo needs different value, you can enter it here. So this small value will cause the servo to go to the minimum angle, and this highest value will cause the servo to move to the highest angle. And inside the setup, this code will run only once, and we use that object that we created here, my servo.attach. So we are attaching a pin to the servo, and we bring the pin number. This is as if I type here 25, and then we give the minimum and maximum of the width for the pulse. And here we set the pulse modulation signal. My servo set period in hertz, that's a 50 hertz. And inside the loop, which starts from there to here, this will run continuously. And we have one for loop which runs, and then we have another for loop. This for loop has a variable called angle, which starts from 0, and it goes up to 180. And every time the for loop runs, I've explained the for loop in separate video. Please make sure to watch that video. I've explained the for loop in lesson number 7. It becomes 0, and here it's incrementing it, adding 1, 2, 3 up to 180, and then this loop will exit. So this value changes every time, and we have an integer called pulse width. We are mapping the value. When we want to send a servo, we write my servo, write microsecond. We have to give the microsecond value. So for each angle, for us, it will be hard to understand. For example, 100 degree is what? So we use the map, which get the value, for example, 100 degrees, and we say this 100 degree starts is within 0 to 180 degrees, which means it will never be out of this bound, and we pass minimum and maximum pulse width, and this will do the calculation. And if you enter, for example, 0, it will give the minimum. This will be 500, and if you enter here 180, it will be 2500. So this is mapping the value, and the result is set here, and it goes to the servo. Servo moves to that angle, and there is 15 millisecond delay, so the servo has time, and it goes up to 180 and exits. Now this loop is the opposite of that loop. It initially starts with 180, and as long as it is greater than 0, now this time it's decremented. Here it was increment, so it goes from 180, 179, 78, 76, and so forth until 0, and it will exit. And the same thing, the same calculation is done. Nothing is different inside it. And once it finishes, it comes here, and it goes back and sends the servo back from 0 to 180, and this is 180 to 0, and the loop continues like that. After selecting port and board, click on this icon to upload the code. Upload it. Now it will start. So as you can see, it goes between from here to here, 180, and if you see a little discrepancy, This is the quality of the servo. Now let me connect the other servo motor that I have. I'm removing it so nothing is different. Exact same thing. Make sure the black is connected to that side. So it comes from here and the other side comes back. So that's 180 degrees. And here this one has a little sound. I've connected the battery and it is on. Now we are getting 5 volts from the power. I'm disconnecting the USB. Now let's see if we want to control this with ESP32. Because this needs higher voltage, I'm going to connect it to a source that is about 7 volts. Let me connect it and show you the voltage. And it's 7 volts. This from my 7 volts, red on this side, and the other one on this side. So red on that side and brown on this side. So this is negative, that's positive. And let's connect the common from ground to there, and that is fine. Now I'm not going to connect this pin because this is 5 volts. So the signal goes to the white. And here I'm going to get orange and yellow. So this red is connected to that. This metal pin should be connected to the positive. I'm going to connect some red wire, and it is connected to 7 volt. This is 7 volts. And now we need to connect the common to the board and to the power supply. Let me connect this wire. This is yellow, and I'm going to connect it to the ground. Now this is running. Let me disconnect it and put this arm. Now so this is 270 degrees. 180 was there, right? So 180. So this goes up to 270. So don't forget, when you power it up with external power, signal comes from the ESP32 to control it, and power comes from external, but the ground should be common between this and the board. There should be this black should be connected to this board as well as the power supply. Do not also forget that we should supply power to the ESP32 from either battery or USB, because external power is supplying power only to the servo motor. And here, if you just want to send the servo without this loop or rotation, we can do it like this. Just copy this portion. I'm copying it and placing it inside the setup, and then I will remove everything from the loop. But you can do the same thing. So we need, everywhere you need this 2 line. So let's say you want to send it to 100 degrees. Just put here 100, and this value will go here, and this line will send the servo to our 100 degrees. Sorry, this was 100. So let's upload the code. And let's upload the code. And now I'm powering it up. and it went to 100 degrees. You can send your servo to any angle you want. Just use this. You don't need any loop or anything. Now let's see how we can use a potentiometer or variable resistor to control the position of a servo with ESP32. And now first let's insert this variable resistor or potentiometer. If you look at it from the top, this side is out, so I'm going to insert it like that. And a breadboard, so we have 3 holes ready for us. I'm going to put one blue at the middle. I'm going to put black to the left, and then red to the right. These 3 wires are side by side. Connect this red to the 3.3 volts. Connect the black to the ground, second pin. And connect the blue. Connect the blue to pin 34. And let's open the code. Click on File, Example, ESP32 Servo, knob. Click on the knob. Here is the code. This is the line that includes the library, and then from the library we create this object called my servo, and we are defining pin 18 for the servo in this section, and this is for checking different type of ESP32, and depending on that we are setting the potentiometer pin. Our case is 34, and then the maximum analog to digital converter value is 4096. This variable is holding the potentiometer value. So ESP32 pulses modulation, timer 0, 1, 2, 3, and 4 is also allocated, and this is setting the standard servo at 50 Hertz, and we are setting the servo pin with my servo attached from minimum 500 to 2400 microseconds. Inside the loop, we are reading the potentiometer using analog read with a pot pen, and the result is a value from 0 to 2000 and 4096, this value. And it will be stored in a variable called value, which is defined in here. And then we use the map, get this value, which is from 0 to maximum value of 4096, and we are mapping it to a value between 0 to 180 degrees, and the result of this calculation is stored in here, and we use my servo.write. We write this value to the servo, and with 200 millisecond delay it will come back. Now if we want this one to respond faster, we can make it 50, and let's make sure that port everything is selected, and make sure the port is selected. Okay, and then upload the code. Put it fully. And now I'm disconnecting the external power, the USB, and turning this on. So my servo is here, and let's turn the potentiometer. As you can see, when I rotate it, the servo moves. If I go backwards, so I can move it 180 degrees from here.